All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to want to do remove, replace, reduce. So we're going to remove the 4 and make it x squared plus 20x plus 100. Then when you factor it, we can also replace the 4 that we removed, and we're going to have 4x plus 10 times 4x plus 10. And then both of these will divide by 2, so we'll have 2x plus 5 times 2x plus 5. Or you can write that as 2x plus 5 squared. For the math knowledge question, we have a trapezoid here. The base length, they tell you, is 13.5, and then the top is 11. So to find the median, you're going to add 11 plus 13.5 and divide by 2. And if you do that, you get 12.25. So that would be your answer for your math knowledge question. Okay, so today we're looking at lesson 38. We're going to be looking at the fundamental counting principle and permutations, designated roots, and then overall average rate. So hopefully you'll understand the fundamental counting principle and permutations, designated roots, and overall average rate after this lesson. The letters A, B, and C can be arranged in 6 different ways. So I want y'all to pause the video real quick and try and come up with all 6 ways that they can be arranged. All right, so now that y'all have tried that by yourself, these are the 6 that you should have. You may not have them in the same order, but those are the only 6 ways. So if you have more than 6, you wrote the same arrangement more than once. We call the arrangement of the members of a set in a definite order without repetition a permutation of the members of the set. So there are 6 permutations of the letters A, B, and C. These are our 6 permutations of A, B, and C. The example is going to be a demonstration of the fundamental counting principle. So I'm going to show you how I know, before I even rewrite them, that there are 6 ways. We have 3 letters, A, B, and C. So we can put any of the 3 in this first block. After we pick that first letter, let's say we pick A, now we only have 2 letters left. So 2 of them can go here. And then once we pick one of them, we only have 1 letter left. And so if you do 3 times 2 times 1, you get 6. And so that's where the 6 came from. So this is the fundamental counting principle. If one choice can be made in A ways, and after that choice is made, another choice can be made in B ways, then the number of possible choices in order is A times B different ways. So if you allow repetition, then the number of possible arrangements will be even greater. So if we arrange A, B, and C, and we can use them as many times as we want to arrange them in 3 sets of 3, how many ways could they be arranged? So we're arranging them in a set of 3. So y'all see if you can figure that out real quick. All right, so if we can pick A, B, or C for the first slot, then there are 3 ways we could pick those. But it says if repetition is allowed. So again, we can put 3 here because we could use A, and we could put A here. So we could do 3, 3, and 3. So if you multiply those, that gives you 27 different ways to arrange A, B, and C if repetition is permitted. So if you allow repetition, you're going to have a lot more arrangements allowed. So let's look here. How many different ways can the numbers 3, 5, 7, and 8 be arranged in order if no repetition is permitted? Okay, so we have 4 numbers that we're arranging, and we're not doing repetition, so no repetition. So in the first slot, we can put 4 options, any of the 4. Once we pick that one number, we have 3 options that can go here. Once we pick that option, we only have 2 that can go here, and then in the last slot, we only have 1 option. So if you multiply these, you get 24. That's how many different ways you can arrange this. And that's how these work. We're going to try another one. how many 4-letter signs can be made. So we're going to have 4 slots. And it says if repetition is permitted. Well, we are using the letters in the word equal, which are 5 letters. So any of the 5 can go in this first slot. And it says since repetition is allowed, that means that any of the 5 can go here, or here, or here. And so when you multiply these, you should get 625 different ways. Okay? Looking at another example. A multiple choice test has 8 questions, and there are 4 possible choices to each question. How many different sets of answers are possible? So we have 8 questions, and in each of them, we have 4 possible choices. So on question number 1, I can pick A, B, C, or D, any of the 4. On question number 2, does it depend on what I picked for number 1? No. So I can again pick A, B, C, or D. Same thing for all 8 questions. You pick any of the 4. And so if you multiply each of these, you should get 65,536. And so that would be your answer there. Okay, so I want y'all to try this next one by yourself. How many 3-letter signs can be made from the letters in the word numeral if no repetition is permitted? So y'all try it, and then I'll go over. So we're making 3-letter signs, so we have 3 slots. 1, 2, 3, 4, 5, 6, 7 letters. So any of the 7 can go in the first slot, but it says no repetition. So we only have 6 options now, and then once we pick it, we only have 5 options. And so if you multiply, you should get 210 options. Okay, so that's how you do permutations. Now we're going to look at designated roots. We're going to write the quadratic equation with a lead coefficient of 1 whose roots are -3/5 and 1/2. So before we get here, I'm going to start with, this would be x squared minus x minus 6. That's a quadratic equation. The lead coefficient is 1. And if I solved it, x would equal 3 and -2. And these are the roots. So normally we start here and then we factor it and solve for x. Now we're going to be given the roots and we're trying to get back to the original equation. So the way you do this, x minus 1 root times x minus the other root. So x minus a -3/5 times x minus 1/2. And it's an equation, so you do need to make it equal to 0. And then from there, all you have to do is distribute. So x squared minus 1/2 x plus 3/5 x minus 3/10 equals 0. And then if you combine these, common denominator would be a 10. So x squared, this would be -5 plus 6. So that's going to be plus 1/10 x. And then minus 3/10 equals 0. So that would be your quadratic equation. Most of the time, the people forget to change the signs there. It's x minus the root. That's usually the most commonly messed up part. So let's look at another one. Oh, there we go. So they give us the lead coefficient of 1, and I'm almost positive that all of them that we cover have a lead coefficient of 1. Okay, so you don't have to worry about what is it going to do whenever it's not a lead coefficient of 1. Pretty sure all of them have just a 1. So the roots are 1 plus the square root of 2 and 1 minus the square root of 2. So again, we're going to do x minus the root times x minus the root. And the reason I'm putting parentheses, we have 2 parts here, so we need to make sure to distribute that minus sign to both of them. So we end up with x minus 1 minus the square root of 2 times x minus 1 plus the square root of 2. People typically forget to distribute the negative, and sometimes that'll mess you up. So that's why I started off with the parentheses. Now you have to distribute it. So we're going to have a x times x, which is x squared, and then minus x, and then plus the square root of 2x. And then we have minus x plus 1, and then minus the square root of 2. And then we have minus the square root of 2x plus the square root of 2, and then minus 2 equals 0. So those are your 9 terms that you should get. And then if you look, this minus square root of 2 and plus square root of 2 cancel out. And this plus square root of 2x and minus square root of 2x cancel. And then from there, we have x squared minus 2x minus 1 equals 0. And so that would be your equation. The way that you can check these is either to factor them or to just use the quadratic formula and simplify. This one doesn't factor, and so you would use the quadratic formula. But if you use the quadratic formula, you would get x equals plus or minus square root of 2. On the last one, if we had tried to factor it, you may would have wanted to multiply by 10 so that you have 10x squared plus x minus 3, and then factored it using remove, replace, reduce, just to get rid of your fractions. Otherwise, you could have tried to factor it, or you could have done quadratic formula. But that's how you can check and make sure that your equation should give you the 2 roots that they gave you to start with. Okay, so now we're going to look at overall average rate. Overall average rate, or, is the total distance over the total time. Distance equals rate times time, and if you divide by t, rate is distance over time. So it's that same formula, but we're looking at overall average rate. So let's look, we have 2 examples to look at. It tells us Frank and Judy drive for 100 miles at 50 miles per hour. Then they drive for 180 miles at 60 miles per hour. What is the overall average rate? So it's not just going to be 55, because it's a weighted average, because they went longer at 60 miles per hour. So that means that it's going to be closer to 60 than 50, because they went at 60 miles per hour for an extra 80 miles. So our overall average rate is our total distance over our total time. So the distance, we went 100 and we went 180. Now the time. If we went 100 miles at 50 miles per hour, how many hours is that? Should get 2 hours. And if we went 180 miles at 60 miles per hour, how many hours is that? 3. Now if you add those together, you get 280 over 5, which if you divide is 56 miles per hour. So that's their overall average rate. Okay, we're going to look at one more example. They drive the same 2 that they just did, and then they want to overall average rate of 60 for the entire trip. That's what we want to have. So we're going to start off with our formula. Overall average rate, they want to be 60. So we know that it's supposed to equal 60. Our distances are 100, 180, and 120. And then we already figured out the time for the first 2. That was 2 and 3. We don't know how long they're going to take on the last 120 miles. But we know that when we divide all this out, it's going to equal 60. So we can combine. 60 equals 100 plus 180 plus 200. Plus 120 is 400. And then over 5 plus t. And so I'm going to cross multiply to get 300 plus 60t equals 400. and then 60t is going to be equal to 100. And then t is going to equal 5 over 3. So that's the time that they're going to spend on the last leg. And so we're going to go back to our distance equals rate times time. They're going to drive 120 miles. We don't know the rate. That's what we're trying to find. And then we know that their time is 5/3. So I can multiply by 3/5. And that's going to give you your rate. And if you simplify that, your rate is going to be 72 miles per hour. So that's how fast you would have to drive to average 60 for your whole trip. So sometimes they'll ask you for questions like that, and you'll have to start off by setting up your formula and solving for your time. But this isn't the final answer because it says how fast did they have to drive, not how long. So that's how ones like that would work. Okay, for your homework tonight, you have 2 questions you get to omit, number 12 and 27. And then you're going to have your next trig quiz whenever you take lesson 40. So make sure that y'all are studying your unit circle. It's going to look identical to the last one, just with different numbers. So if you did well on the last one, then keep studying. You'll probably do well on the next one. If you didn't do very well, then you really need to study. 24 points, okay?